In this second module, we are going to discuss a new technique of integration called integration by parts. Here, we are going to see 4 different types of example. In the techniques of integration, you have to first cast the integration into a specific form, which involve 2 functions, u and v. Let us look at the first example. The integration we are going to integrate is x times e power x minus x. We have to identify which terms in your integrations should be identified as u and dv. In this particular example, we are going to identify the function u as x, whereas the differential of the function v, which is dv, to be the product of e power minus x and dx. You write down the function u as x and you write down the differential v e power minus x and dx. The choice of u and dv as is shown here is by no means unique. However, if you make the wrong choice of u and dv, you will probably land into a situation where you cannot perform the integration correctly. Once the choice of u and dv are performed, then the next thing you want to do is to write down the differential of du. Here, du is dx, whereas for the differential of dv, you want to perform an indefinite integral, which is e power minus x and dx. And you'll be led to e power minus x with a minus sign. And since we are talking about an indefinite integral, by right you should add in a constant to here. However, in the special case of this method, you will always associate the constants to be just simply 0. Now, once we have obtained this relationship, then we can proceed with the integration by part quite easily. So here you rewrite the integrations to be u du, and you express it to be the integrations of the product of the function u, v, minus the integration of v du, where the expressions of this function v is obtained from performing the indefinite integral on dv. So here we would take v to be minus e to the power of minus x. The next thing to follow is just to copy down the expression for the terms u, v and v du. Here u is x, v is just minus e minus x, minus the integrations of v du. V here would be minus e minus x. Du is dx. So here you got an term of e power minus x multiplied with x plus the integrations of e minus power x like this. And the answer is just equals to e power minus x. And since we are performing a indefinite integral, the answer for the integrations would then requires you to put in a constant. So this would be the solution that is solved on the integrations u dv using the integration by parts formula. As a conclusion, we have shown you how to perform integrations of example 8 by using integration by parts. We first cast the integration into the form of u dv, and the integration of u dv according to the integration by parts method is equals to the product of uv minus v du. And we have to choose which term in the integrand is to be identified as u and which terms is to be identified as dv. Here we choose u to be identified as x in the integrand. E power minus x dx is identified as dv. With this choice, we derive what is the expression of v by integrating dv. Then we obtain what is du. With the expression of v and du, we can then obtain the integration of u dv by slotting in the expression of u v du to transform the integration into this form, which is easily integrated to give us the solutions that is shown.